Mm. All right. Hey, everybody. Hope you're having a wonderful day so far. My name's Michael. Welcome back to my stream. Oh boy, you guys. Oh, wow. Wow, 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 wow. Your boy's been nervous all day. So last night, we got word. Well, let's wait for some more people to roll up in here, actually. Let's before we get started here. Let's do. Yo! Here we go. I like this one. How's it going, everybody? Welcome in. Welcome back to the stream. Hey, DevGod, welcome on Twitch. Thanks for being here. Tim, welcome back, dude. MD Austin, MD Explains, Naman, welcome in, you guys. Let's go! All right, you guys, welcome back to the stream. Hope you guys are having a wonderful day so far. My name is Michael, and today is June 23rd, 2025. We are going to be doing some practice problem interview prep today, right? So I have a live coding interview for a software engineer position. Ah! Oh my gosh, you guys. I do have an interview this Thursday for a software engineer. It's a live coding interview. I've already gotten past a take home and a screening. So it's a live coding interview. I'll be asked two problems, I think. And it's kind of interesting because the notes of the interview said that data structures and algorithms memorization not required. Oh boy, are times changing? Oh my gosh. Well, I'm nervous, MD. I'm super nervous, you guys. Like, I'm gonna be straight up. I've been sweating through my shirt all day. I could barely really focus like at work. I was just thinking it's in the back of my mind. Like I set it for Thursday so I could have some time to study and do some more practicing. Um, right? But and that means I just have to sit here and wait now. I was always the kind of guy when like in speeches and class, I would always go first. I just get that thing out the way, man. So I could have. Yeah, it's interesting. It says that it's not memorization of DSA is not an algo. Yeah, DSA is not needed. So we're going to be asked some real world problems, I think, similar to kind of what my take home problem was, but maybe not on such a grand level. It might be more of a smaller level because that one took like about 2 hours, and the interview is only for an hour max. And so, and I think a little bit of it might be getting to know the person, or just kind of introduction. So, anywho, I went ahead and prompted the Jippity for some problems to work on for some real world cases. I kind of explained my situation here, and so we're going to give it a go. And hopefully we can do well on these. So I'm going to create a directory here. We'll just call this interview prep. Right, let's just go into here. Let's just let's code here. So we need to, let's set up some practice problems. So right, let's do this is going to be 6/23/2025. Okay. All right, let's see what we can do here. So I was given some problems here, and we're gonna give them a go. Just some I had ChatGPT give me kind of like a 3-day roadmap of things to solve for real world cases and like real world solving and things like that. So we're gonna give it a go here. Let's go ahead and let's make a new directory here called mass analysis. That's what the problem is called here. And we'll create a new file here called main.py, or we'll say mass analysis. Right. And then I'm going to go into here and create a new file just called temp, just so it's structured differently, okay? Chill. All right, so we're going to, let's go ahead and create a new file here. So this is mass analysis. Let's go ahead and create we'll call this, we'll say data.csv. Okay, and then I'm going to take this data that we were given here. Okay. So our task for this problem, you're given a CSV named molecules. Okay, let's say molecules.csv. Sorry. All right, you're given a CSV named molecules.csv with this structure. Write a Python script that reads the file CSV, parses each row into a dictionary or list, and returns the top 3 heaviest molecules sorted by mass, descending. Prints the results of this format, name and mass, 1 per line. Okay, so I'm going to bring this over so you guys can see. Okay. Okay, so yeah, we could use pandas, or we could just use Python CSV. It says optional, don't use pandas yet, let's just use vanilla Python for now. Okay, so, and I don't think there's going to be like any, I'm not sure maybe if they're going to make us use pandas or not in there. I don't know too much pandas. We do know the basics of pandas and SQL and stuff, but much more familiar with Python CSV. So we're going to use the built-in CSV module here. So we're going to read the CSV file. So we're going to say, have a function here called def. We'll have def read CSV, which is going to take in some path, which is going to be a stir, right? And then we're going to return a dictionary of all the objects, right, within the CSV. So let's go ahead and maybe I should practice this without music so I can talk through my stuff, because I'll have to turn it just low for me. Let me know if it's too loud for you guys. Now the The job description, all that it said was that you had to have a degree in either CS, biology, or chemistry. You had to be able to write Python scripts to, parse data, just go through data. It said Python scripts. Um, the interview portion in the footnotes for the thing, it said it gave me some like a thing to look at, and it said I'll be asked two problems and a SQL prompt, but then the interview note from the person said to ignore the SQL portion. So there is no SQL question. So they're just going to ask me two scripting questions in Python, really, I think. Okay, so we're going to read the CSV. So let's use our with open constructor to kind of handle this. We're going to open up this path provided we want to do it in read mode. And then we're going to say new line is going to be just a empty string here. We are going to say as file, right? So let's go ahead and call the so if we want to read this in as a dictionary or a list, so that's interesting. So we would probably want to read this in where each row would be the item. Let's just automatically import it as a dictionary using the CSV dict reader. So let's say that dict reader is equal to the csv.dictReader class, and we're going to put in the iterable of our file here. Right? Does it go file into the dict reader? Iterable like a type stir. Yeah, I think so. This opens up in read mode as file. We parse this with here. And then, do we want any additional C? No, we don't need any additional things, I think. So let's just quickly, let's just see what we get here. For row in, and then let me actually return here just to see what we get. The dict reader. If you guys have any feedback, let me know, like interview-wise, how I'm talking through this. I'm trying to talk through my stuff, and maybe, I don't know. So let me know. So we're going to read the CSV. We're going to open the path. Use the dict reader to read and kind of format the reading of this file, the content. And then we're going to return this just to see for now. So now if I call the read CSV, let me also define a path here as molecules.csv. And let's call, this will be reader is equal to here, read CSV, and let's call path, right? Then let's say for row in reader, let's see if we're getting input here, print row. Well, this is going to give me a dictionary object, right? So I think this will still work. Row in reader. Let's just print the reader, the row. We need to go through the individual rows. Does the plain iterable without the items work over this? Let's see. No such file. So let's go ahead and add some safeties here. So let's say try. And we need to, or no, sorry, not there, my bad. We're gonna go here and say try, and we'll with open here and return, except if we get a file not found. Error, let's go ahead and print error, or we'll say custom error file not found. Boop. All right, so now we should get this custom error on this, right? Actually, it's doing that error, so it's not of type iterable, right? Of the reader. Reader is none. Tim, you're funny, McGay. Okay, so we're gonna read the file, the path. We're gonna with open in read mode, new file as file. Under csv.dictReader on the file. Which we have the reader here. And we return the reader. So if you print reader here, is this giving you a none type object? Yes, it is. Custom error file not found. So it's not reading our molecules.csv. Because we're in, what are we running on? Interview prep. So we need to go. We need to cd into these. Okay, so now if we run from here, we get the dictReader object. Okay, we just need to get our terminal to the right scope here. So now if I say for row in reader, let's print the row. IO operation value error, IO operation on closed file. IO operation on closed file for row and reader. We were getting the dictionary object back before. So if I call reader.items and just print like for key value in reader, print just the key, but I still get that error. dictReader has no object attribute items. Okay, interesting. Okay, so the dictReader itself, this is what it's for. We're doing some studying. So the csv.dictReader. Create an object that operates like a regular reader, but maps information in each row to a dict whose keys are given by the optional field names parameter. Okay, so yeah, oh, we're missing the field names. So the field names are going to be name. So this is a list, right? Name and mass. Rough start, boys, rough start. It's all right. Still have no attribute items, that's fine. So let's just do the for row in reader for row. Still getting this on the file on the closed operation. So you have to do something with the reader object before you give it back. So I'll just do it here then. We'll just see what we're getting here. Rough start, boys, rough start. Rough start. For row and dictReader. Am I not using this dictReader right? Huh. So this should be doing something. Mass analysis. Interesting. trolling? What's going on? Oh, I don't have my path here. That's just good. Come on, Mike. Okay, let's just call read CSV on molecules dot CSV. There we go. Gosh, Mike, come on. You're making this hard on yourself. You're not making this easy on yourself, my guy. You know what to do. You're just making dumb mistakes, bro. Oh, my goodness. Hey, Komodo, how's it going? Hey, Douglas, how's it going, man? All right, we're good. We got our stuff now. Name and mass is each. Oh, these are each dictionaries, right? Given. So now we need to sort based on this mass. So we're going to return dict reader here. If I say temp here, do I get that same error? Do I get that same close error? I do. I wonder what this is. Is this because I'm returning a dict reader object outside of this function, and so it's closing this file with open already? So do I need to say like dict reader here is equal to none? Return dict reader by having it set outside here? No, that still doesn't get it done. Okay. So I want to actually take this. I want to learn more about this error. Let's say okay, yeah, so it's just closing with open within this function. So then let me say I can just write, this is just let me just call a list on this. And now I can print this. There we go. So now I just need to sort this list based on mass mass value, right? Okay, so we need to be better here. So let's say given a file path to a CSV, open the CSV and return a list of, so this is going to be, sorry, a list of dictionaries. Return a list of dictionaries where each dict is a compound or is a molecule with keys of quote water and so I guess we can like an example here. We'll say right. Okay, so now we have that. So let's go ahead and write a function now. Def sort data or sort molecules given a key right, which is going to be a of type str, and we're going to return no, we're going to turn let's return a new list, I guess. Let's return a list of dictionaries. Right, okay, so we'll say given a key, so this is going to be key correlated to a key, sort the list of dictionaries based on that key. We want to do it in descending order. Okay, so let's think about this. We can use now, do we want to use just a built-in Python sorting algorithm, or do we want to use or write our own? That's the thing. So let's just first see. Let me call a print on a sorted call of so we need to pass in, sorry, the key. We'll say data, right, or molecules type list, right? So we'll call sorted on the molecules. We'll give a key here equal to, let's go molecules index of quote mass. So this will go into molecules. No, we need to go into molecules. No, so this wouldn't work. We would have to do, because molecules of list, needs to be an integer. So do we need to write a lambda function to sort on this? Oh, lambda functions. Crap, you guys, it's been a long time. Right, because we need to sort on the key here, or the value. Let me oh, I got you. Yep, I was exactly right. So we're going to use a lambda function where you say, okay, we're going to use a lambda function to sort on a value of the molecules list, right? Inside of the molecules list, molecules key of mass. Is it this, or is it just... No, so we need to use a different variable here, right? So let's just say, let's just use like x, right? So in descending order. So descending order means we want to do this and then say, right, what is it? We say reverse. Equals to true. Oh, I always forget some of these values within the sorted. If you want to. So let's just actually, I think about this. Okay, so let's just see if this works first on foremost. If with the reverse statement in there, because I think sort molecules on temp. No. Oh, Nikki. Reverse. Okay, yeah. So it is wrong. So we say got unrestricted keyword argument reverse. So we want to say, do we have to put this before key? Like so, and then key. And bada bing, bada boom. No. Did not work. Sort molecules based off of key, so key of mass. First equals true. So let me go here and print temp. We're done for, boys. It's not looking good. We get water first. Okay, so now it's sorting based off of it's sorting based off of the name key. Oh, so we want to do, I think it's maybe key, sort key. We want to put that there for the dictionary key. Oh, interesting. That's right, that was just sorting based off of the first one. Key. Which is giving mass. See, this is sorting off of name. You get B. No, it's not actually. You get B, E, C. Oh, I got it. Do we need to float this bad boy? There we go. All right, it's a float. Okay, so now let's go ahead and return the top 3 heaviest molecules. Oh, the top 3 sorted by mass. So we didn't really have to sort this. Oh well. We could have just parsed through it and got the top 3, but okay. So now we can just so now let me actually call just molecules dot sorted, or dot sort actually, so I don't have to have the overhead of creating a new list and stuff. Let's just call this on here. I think this will work. And then we can call print temp here. And we get the same output. Perfect. So now, if I go ahead and say, let's say def top X molecules. Let's go ahead and get, or we'll say heaviest X molecules, right? Which is going to take in the molecules list. And then this is going to return print. Okay, this is going to return a stir. Well, it doesn't return anything, it prints, right? Or return the top 3 and then print the top 3. Okay, so we're going to return a stir. Or actually, let's just return a list, right? And then let's just return molecule, and we need a an X here, which is going to be an int. So this is going to say, given a list of molecules, which are type dict, reach and an integer, return the top, return and print the top X molecules, or the first X. Actually, I'll keep this as top X molecules, right? It's going to be more universal. All right, so top X molecules, we're going to return the molecules list with a slice up to the top X molecules. So 0, you want 3, 1, 0, 1, 2, right? So up to the top X molecules. Now, you would obviously want to check, so if molecules, or if, I mean, for all of this, this could apply, right? I'm not sure how strict they're going to be on, like, instance checking of, like, types, right? If you have types in here for type hinting, are they going to be super strict on, like, instance checking? Like, if instance, so if molecules and is instance molecules of types list, right? We're going to return this. We also are going to have a check and length molecules. I mean, you could have all sorts of checks in here, right? If the length of molecules is at least X, right? So at least less than or equal to, or at most at least X is greater than or equal to X. Then we'll return molecules. Right? So now, let's see. But let's also say, before we do this, let's call, it wants us to do the print. So we'll save this as a temporary variable. We'll say top x is equal to this. We'll say for molecule in top x, return, or sorry, not print, or actually we'll say like this. For name and mass in top x, we're going to print quote name and mass here. Right, this is going to be a stir, so we need to float this guy. So then let's return the top x here. So now let's call top x molecules on temp. Oh, we need one more thing, right? And the top x of, let's say, 3. So top x has to be of type int as well, right? So if, I mean, we could have all these types of checks and value errors. So like, if molecules, so we could say if not molecules raise, I'm not sure, see, I don't know how strict they're going to be on like all these like super checking stuff. I mean, probably better to have it than not, right? Value error, custom error, molecules list empty, right? Like if not instance of this molecules if it's not a list. So you want to check if it's a list at the start, maybe at the first check you would want to do. If it's not a list, then we're going to, you know, raise the custom error molecules not of type list. If not molecules, raise no molecules in list, right? And then if length of the molecules is greater than or equal to is not, can you go like this? I can see. No, you can't. If length, how do I do not greater than or equal to? Oh, just less than? Stupid. Length less than x. Then raise another value error saying not enough molecules in list. Right? So then if we pass all these checks, we'll go ahead and do this. This object has no attribute items. Oh, whoops, sorry. Okay. We're gonna say just get the 1. We don't really need to do this. Let's just print molecule, index of name, and molecule quote mass. Boom, solved. All right, we got it. So now what I would do here is I would take these functions, close them up, right? Def main here, paste this here, go here, go if main, right? Cool. Nice. All right. Hey, Douglas, how's it going? All right, we solved that one, guys. Not too shabby, not too shabby. How long did that take us? Too long. See, I don't know how I'm gonna solve. I'm just not fast enough. That's my worry. I'm not fast enough. I'm gonna have to solve 2 problems in an hour. I need to give maximum 25 on each. Hopefully, my goal would be 20 minutes. So clearly, I just need to work on clear takeaway off of that problem. Let's get some. Let's make some notes here. So clear takeaway off of that problem. We'll say this is 06, 23, 2025 practice or interview practice. Okay, hold on. We'll say interview practice problems. We'll say this is 06, 23, 2025. So clear takeaway for problem number 1, mass analysis. We need faster file handling, instant use of, right, faster file handling without file not found errors, right? We need to instantly use the use try except to catch file not founds, right? Any other takeaways you guys have for that problem? Obviously just better slash more fluid conversation or more fluid describing or talk through. Right. Any other potential things? So what do you guys think? Anything else we want to? We used doc strings. We didn't use any comments really. No comments were used. This is going to be bad. So I'll say slow file handling. Didn't instant. We use try except catch file handlers needs better. Fluid talk through. No comments were used. Okay, what did we do good there though? It took too long, right? We took about 30 minutes, 35 minutes. AMD, hey Abdul, how's it going? Jim got you crawling, got those legs shaking. Okay, so what did we do good here? Okay, so good. Right, we solved the problem. Right, we used type hints. We tested functions while writing. We included multiple error catches. We used custom lambda function within .sort. That was pretty cool. We recognized that. So we needed, this is needed to look up syntax for csv.dict reader and lambda sort. Okay. All right, that's pretty good. We're not going to grow ourselves too hard here. Okay, practice problem number 1. Don't use pennies. Right, and share your solution. I'll respond with feedback. Okay. Okay, I was able to solve the problem in about 30 to 35 minutes, which is pretty slow. I def need to shave about 10 to 15 minutes off, but this was with no warm-up. Here are some of my reflections on my own work. You're doing exactly what a strong candidate should do. You solved the problem, you reflected critically on your own performance, and you're ready to iterate. Let's walk through your submission like an interview it with positive reinforcement, areas to tighten, and a few pro-level ideas for polish. What you did well. Function structure is clean. You broke logic into small, testable parts. This shows good software engineering thinking. Type hints. You're writing maintainable code. Error handling. You include try, accept, and validation, so you're thinking about edge cases and robustness. Lambda and sort. Well done. That's a must-know idiom. Readable and functional output. The formatting looks clean. What to improve for interview setting? Top X molecule string quoting bug. This would raise a runtime error. So we say oh yeah, that's right. So I always forget that. We have to use nested single quotes within here if we're having double quotes for the F string on the outside. That's an error I often get hit with. No return value into main. Main runs the pipeline but returns nothing, interviewer asks. Should the function print, return, or both? In interviews, always ask. Okay, this is good. Should the function print, return, or both? So we need to return here, top X molecules. In place sorting. In an interview, you could say, I'm sorting in place for efficiency, but you could also return a new list to keep this function pure. This shows maturity. Okay, that's a good idea too, right? So in our sort here, we decided to sort, but we could have just parsed through and got an order on our own of top 3 and just return that away. But you could also return a new list to keep this function pure. Oh yeah, I mean using the sorted function, right? So I chose to use sort to sort the molecules in place, but we could use a sorted function rather than a method to sort and return a value. And then leave molecules as it is. CSV reading, field parsing. All fields from CSV dict reader are read as strings by default. Your sort works because you cast float X key, but it may be smart to cast up front if other fields need to be typed later. That's probably a good idea too. So let's remove our float casting off of these, right? Because we were doing that twice, so that really wasn't that efficient. Let's just do it once upon reading the CSV. So it'll happen here when we sort. Or you could, what it's saying is, depending on size, I might pre-process rows in the strongly typed data classes later. So instead of doing dict reader, I could loop over the rows and pre-process them into, the right structure within here, but I'm kind of already doing that with this sorted function. So I'm actually going to just keep my float cast onto here, right? And so because this is taking a sort on the main list, this is still going to apply. 30 to 35 minutes is fine for a first round practice. For the interview, aim to be at 15 to 20 minutes with 5-minute problem verification, 10 minutes of coding, 5 minutes refining edge cases and cleanup. I have to solve this in 10 minutes. Oh, gosh. Gotta get way faster. Hey, Draco. I quit coding because my friend gave it up. Well, don't quit. I'm right here, man. Let's get coding again. Let's test it with this file molecules. If it prints that, you're golden. Caffeine, glucose, benzene. Perfect. Let's test it with this. Okay. Return from read CSV a list dict stir union stir float or convert to data class molecule stir float. Add a test harness. 8.5 for day 1 practice. You're in excellent shape. Thank you, dude. Sorry, I cannot pronounce your name. I can't read. Is it Russian? Looks Russian. I'm not sure. Thanks so much for coming in here, dude. Can I call you anything else? How do you pronounce it? Okay, cool. So we solved that one. Not bad. Not bad. Sweet. Let's go for another one. Borowski. All right, let's go for another one. 8.5. Not bad. Okay. George, nice. Bulgarian, same kind of alphabet. Oh, gotcha. Nice, it's great to have you, George. Thanks for coming in here. Okay, so let's go Okay, let's go ahead and try another question. I am going to ask you some follow-ups to simulate me asking the interviewer. All right, I'll give you a fresh problem here. Okay, here we go. Let's open up a new folder here. Or let's rename this guy to, this is going to be experiment log. Experiment log. Okay, let's go ahead and open up a file here called experimentlog.py. And then let's open up a file. This is going to be, you've given a log file named experiment.log. Okay. I've never worked with a log file before. Interesting. So let's copy this information into here. Oop. Write a Python script that parses the file and pairs each experiment start and its corresponding end or fail. Write a Python script that parses the file and pairs each experimental start and its corresponding end or fail. Okay. So we need to use a log file here. I've never actually used a log file before. I'm going to be transparent with you and say that. I'm not sure we should say that to the interviewer. But never used a .log file before. But we could open this and read lines, right, and extract out things. Okay. Let's see here. Experiment log. So I'll say, I have never used a .log file before. A .log is just a plain text file with log extensions. There's nothing different about reading it compared to a text file. It's still open with Python's open function. Okay. Okay, so I would want to, if I was going to okay, so all these are back to back. Okay, let's do this. Okay, so let's define a function here called open or read log, right? So we read log, given a path here. So I'm going to go down here and just add some test cases here, such that the path is equal to a string, and we'll go experiment.log, right? And then we're going to go call the read log on the path here, okay? So let's go ahead and say with open, let's open up the path in read mode. Blank lines will be just an empty string. Okay, and then we'll say as file or as log file or whatever. And then we'll say file lines equals to log file dot read lines. So we're going to read the lines of the log file. Don't need a hint here. So this is going to give us a list. But we're going to also want to use a try here to open up this file. And then we'll also throw an except on here for a file not found error. Oops, spelling error. Right, we're going to print just a custom error saying experiment log file not found. Okay, so let's read these lines. We'll say if file lines, return file lines, right? So no matter what, it's going to return file lines. So let's just return. Actually, we'll say return file lines, and then we can catch this. If not, else, let's raise a value error here, saying that custom error file is empty. Right? Perfect. So that'll return the file lines back to us. Now let's go ahead and say, I'm getting a call, one sec. So that's exactly, Abdul, what I was going to think of. Like, I think we could probably use, like, let's import regular expression here. I was thinking about doing that as well. So like if we import regular expression, or is it just RE? Yeah, import regular expression. Let's say def parse lines given file lines of a type of list of a type of stir, right? This is a path of type stir, forgot that. This is going to return to us a value of a list of type stir. Okay, and then this is going to return, I'm not sure yet, we're going to figure that out. So we're going to, let's create a start code equals to this. Let's say a end code is equal to something, and then a fail code is equal to something. Yeah, here, sorry, file lines. All right, you gotta chill, MD. I'm gonna time you out. It's nothing to do with programming, for real. People get too bold in chat. internet is too wild. Too much power behind a screen. Okay, each line is a string. You'll just need to parse the timestamp, extract the event, start and end fail, track experiment names, and match their start and end dates. Okay. Okay, so this is what we're gonna do. I'm gonna parse the lines. So let's use regular expression here. So let's use a raw string. Ooh, we gotta remember our regular expressions here. So if this is what we're trying to extract out, so we're going to extract out a literal I'm not sure if we have to do this for that, but we might. Let's just keep it there just in case. So a literal bracket with some type of, now are these integers? Or is this a string? This is going to get read as a string, right? So, okay, so it's going to get read as a string. Okay, so what we'll do is we'll make a group here, two groups, split off by a space, and this is going to be called, this is going to be, what is it? Any word character more than once, or let's say any character more than once, right? And then we'll also do that here, any character more than once. We have a literal bracket, we have a space, we're going to have a group here for any word character more than once. Oh, sorry. Is the dot any character and then the asterisk is more than once? The dot might be any character, and then the asterisk, is that means more than once? My regular expression, okay, so then if we say any word character more than once, then we're going to have another group, right, called the experiment, which is going to be any character any word character more than once, space, and then a single word character one time, right? So start code. So let me just first, let's just see if we get this out of there. So we read the path. Let's say, so what is this going to do? Let's say for line in file lines, if we're going to call re.find all instances of the start code, and then let's return, let's save this as a temporary value, and let's just return this. And then let's just go if temp, let's say start is equal to an array of starts. Let's say if temp, right, we're going to starts.append the temporary variable, or we'll say found start, right? And that'll go here. So then if, let's just return the starts here at the end. So I guess we could say though, right, if list, or if file lines, or if, sorry, is instance file lines, of type list, then we're going, if it's not, we're going to raise an error. A value error of custom error file lines input not type list. If not file lines, raise another value error for custom error. No values, no rows, no strings to parse. Okay, so we have a start code. All right, so then if we want to say we add the start, so now let's go ahead and read log, and then we're going to call parse lines on, so read log is going to return back the file lines, right? And then we're going to put in the file lines here. So now are we going to get those? And then let's go, we want to call, let's say starts is equal to here. And then let's just call a print to starts. See if we get it. Come on. Oh, my bad. We got to finish our type print here. So we're going to return so we could turn this into a generator, and we could have it generate the regular expression, the ones that are found on each generation, rather than having it be an iterator, right? So let's go. I think I want to do that, but I don't want to. I'm going to waste time doing it. Let's just put here. I'm going to remove this for now. Input not of type list. File lines is not a type list. This returns a list of file lines. Okay. I call parse lines on file lines. Let's print the file lines here. Experiment log not found. Okay, so it's not finding our log. Do we have a typo in our path? Experiment, exp, yes, we do have a typo. My bad. I always have typos. Where is the, how do you spell experiment? experiment. Okay, none. Customer log fill. Log file not found. experiment.log. Oh, I'm in the wrong. I need to CD down into this thing. Ah, this sucks. CD. Now if I run here, there we go. Okay, so I got my groups here. Or sorry, I got my my lines. Oh. Oh, interesting. Why do you get a backslash tab on the read lines? So I'm calling new line as a blank. I don't want to read the backslash tab. Oh crap. Yeah, we're getting it though with on this read lines here. Why is this giving us the backslash n for the new line here? That didn't happen with my text file or my CSV. Well, because I was using CSV dictator. Interesting. I might have to look this one. Read lines, keeping backslash n at end of line. Okay, so it just keeps that by default so it can write the line again, basically, right? When we're using the read lines method, always returns backslash n. If you want to remove the new line character, you have to use the strip method or rstrip when processing. That would make sense. So, can you call read lines and then for line and file lines? Find all, find match the pattern of start code. Oop. And the file lines and the line we're on, right? So then if we want to, let's call line.rstrip quote backslash n. If I have to, do I have to escape the literal backslash n? A literal backslash n with an escape on that one? Start A, B, A, B. Why am I getting C? Oh, we are. Okay. So let's not call a print here now. We're getting all the value. We're getting all of them. Good. Now let's go here. Getting an empty list. Okay, so we're returning starts with empty. So if found starts, you're not finding anything. So there might be something wrong in our code here. Any character more than once. So this has to, is that the key? Is period any character? I thought period is any character more than once. Oh, not full match, sorry. Find all. So is this even like worth it to do, you think? Because if we find all, the list of tuples for all the groups. Okay, good. So we'll find all here. Let's see. Can I just do that like that? No. I have to say a literal, that, a group, that. Oh, this should say \W. There we go. So this isn't going to say any character, any word though. We got it. Okay, this is going to say start. How do you, could I put, like that? There we go. Haha, we got the starts. Easy. Let's go. All right, so now let's copy this. Put this here, put this, right, and we'll make this come out. End code, this is going to be end. And then the fail code is going to be this, but here with fail. Okay. So we're going to, for every line, we're going to, we don't need to loop over this over and over again. So let's find all. Let's copy this down twice. Find all on end code and fail code. Found end. Found fail. Right? We're going to find all. List all the starts, ends and fails. So then if we want to go we'll copy this. So if you find a start, you're going to continue. You don't need to keep going. Continue, and then you continue because you're only going to find one of them per row. Found end. Ends. Fails. Found fail. Return. How do I want to organize this? Dictionary of all the starts, stops, and ends. So let's return a dictionary of starts, right? stops, or sorry, ends, and fails. Right? So we're going to turn a dictionary of those. Okay, so let's print found is equal to, so we're going to print found index of start. Let's print found index of stops. And then let's print it of fails. All right, we're getting our stops, but not our, okay. If found start. So we're not appending into the ends or, oh, because this is on starts. Ends, fails. Oh, sorry. Fails. If found end, if found fail. There we go. Now we're getting a list of all of our starts, our stops, and our fails. Okay. Within a tuple of groupings because we're finding all here. All right, sounds good, MD. So annoying. All right, so then we have, so now we're getting out all the fails. All right, so then if we want to go ahead and, for parsing lines, using a regular expression, getting all the stops, and ends, we're going to say def org experiments given experiments in the form of a dictionary. This is going to return dict. We're going to return, right, none. We're not going to return anything. We need to calculate these times, right? So we'll say, should we have like a function called calc time, like calc timing, given the experiments? Or should we do it live, like in there? So we're gonna have to, let's just do this. Def, let's just do org experiments. Given experiments as a dictionary, right? What we're gonna do is we're going to iterate over the length, right? Iterate over the length of one of the values. We'll get its starts. Okay, so what I'm actually going to do is I'm going to find end and fails, right? So I'm going to say stops is equal to, and I'll list here, right? If found end or found fail, let's go ahead and call stops dot append the found end if found end, else stops dot append found fail. So now we can remove this and then remove this and put stops here. Put dot there. Okay, so then we're going to organize the experiments. We're going to get the length. We're going to get the length of quote starts. Else it's an empty list, right? If n oh, sorry, typo here, right? So if n, so we're gonna say for I in range of n, right? So every I will correlate to a start and a stop in that order, right? So for I in the range of n, this one's a little bit tricky because we have to do this conversion. How am I supposed to do this in 10 minutes? There's just no way. There's just no way they're going to ask me something like lengthy like this, right? In 10 minutes to solve? 10, 15 minutes? So for I in the range of n, we need to iterate over our start and stops. So I'll say start equals to experiments index of starts, and then this is stops. Right? We get the length of starts. For I in the range of n, what we're going to do, let's go ahead and make a list of strings, right? And we're going to append strings here. So for I in the range of n, or let's just do we're going to create a string that we're going to have be starts right, so starts index of I, right? So it might be easier actually It might be easier actually to organize these in a dictionary already by their. Okay, let's do that. Um, Start, stop, strings, right? So far, we're gonna get the string. We're gonna go into the list of starts. Oh, this one's tricky. So we use a regular expression to find all the groupings, and then maybe what we should do is say if found start. Let's organize it into this format. Let's go like this. So if found start, let's create a string is equal to an f string where we say this is going to be group 1, 0, 1, 2, 3, group 3, index of 3, right? Group 3, index, right? Index 3 or group 4. Experiment, we'll put on here, found start index of 4. Index of 4. Ran for so part of me actually wants to I'm going to switch up my code here. I know we're taking a lot longer, right? But it's okay. I'm learning. I'm getting a lot of practice here, which is good. So what we're going to do is say, rather than looping over the lines and searching for each one, I'm going to have um, a universal um, word here instead of indicating each one, right? And then what I'll do is we'll strip the line and then we'll say found equals to just to the code here, right? And we'll say if found index so I'm going to do like this. I'm going to say open experiment is equal to true here, or is equal to false here. It's not. So you find one if found index of 0, 1, 2 equal to quote start, we're going to set the open experiment to equal true, right? And then what we're going to do if it's start, we're going to save this as start time equals to none, right? Start time equals to none. We're going to, if the open experiment is true, meaning we have an open experiment, we're going to set the start time equal to the group of the start time, which is group number 2, or index 1. So found index of 1. And then what we're going to do is I'm going to import datetime as datetime, right? And then I'm going to say datetime.time on this guy. And then if found index of 2 equals to quote end, right? I'm going to set the start time to it. I'm going to set the start time. And then if it's equal to end on the next pass, I'm going to create a string. I'm going to get the end time. So end time is equal to datetime.time on found index of 1, right? And then I'm going to say and then I'm going to say time diff equals to date time, I'll say, or fail, right? Date time dot time, or sorry, it's going to be end time less than the start time. And then what we're going to do is call time diff dot, we're called date time dot is it minutes? Can we convert to minutes? So this actually looks like a time delta. Represents the difference between two datetime objects. In addition, datetime supports subtraction of two datetime objects. I'm going to look this up. Right, the difference between two times. We need to use the time delta. Yeah, so time delta. Let me look up. Oh, so you increase based on the number of. Got you. So what we're going to do is we'll just take. Okay, what we'll do is this. We'll do datetime dot datetime on found index 1 up to index 2 dot time. We'll slice this up to index of 2. Actually, I'll just wrap this entire thing in just one group. Like so. And then that'll change some stuff. So this becomes index 0. This is start 1. This becomes index of 1. And then there is, so we'll say start equals datetime dot time, end time equals datetime dot time, time diff equals end time less than start time. And so then we're going to create a string called, we'll say experiment. And then we're going to take the group of the indicator, the entry, right? So, or the experiment, which is 0, 1, 2, 3 index, ran for, or say, if it ends, if it's equal to end, ran for time diff, right? So let me go ahead and print. Right, so then else, this is going to say string is equal to string is equal to this failed after this many minutes. So now if we print this, right? So we're going to go through. If it's a start, we're going to open the start. Can I say is local? What's the thing you have to say? So if it's a start, we're going to open it and get a start time. But why is this like, oh, is open. All right. But that's accessed here. If I say, see, it accesses it there. Oh, so it will only access it when if this is true and then hit onto that. So then this is end. And then what we're going to do is we're going to close the open equal to false. Right? I don't think this is going to work right away. Just here. So let's print found here. Empty list. Final code in line. We didn't find anything. Any character more than once. So this should be so I say it's 4, 5, 6, 7, 8, 9, 10. Any character 8 times. Will I get it back here? Getting an empty list. Oh. Okay, there we go. Now we're getting it. So let me just bring this back to this. Okay, so now we're getting the start here. We can't access this found. Index of 0, index of start. Okay, because it's a list. So what if I just say find? Is there a search? There is. So now I just get the singular match. Okay, so let's go. Let's not do search. Let's do the find match or match to this. Now we get the match object. But I want to keep its grouping, so I'm going to use the find all here to keep the grouping. And then now I should be able to access, now it's going to be a list though with an index. So we'll go here and add in an index. Into found. So actually I'm going to not do that. Let me just do this, found equals to found index of 0. Let's just take the only one that's in there, right? and then overwrite it. Okay. So now what we're going to do is take just the first grouping, so index of 0 here on this new found, convert it to a datetime object, and then stir object now be interpreted as an integer. Anthony Simon, Jude Holiday traded to Portland. Oh boy. We're getting a washed up defender? Bruh. Bruh, washed up defender going to Portland. Anthony to Boston. That's not a loss. Anthony wasn't very good. So stir object cannot be interpreted as an integer for found index of 0. Start equals datetime found index of 0, which is a stir. And it's trying to convert datetime. So what is this? Year, month, hour. Oh, come on. Okay, so this is what we're going to have to do. We're going to have to write a function here called def get time, or extract time, right? Or why can we not just run these? What does a date time object look like? Yeah. Okay, so we should in theory be able to just date time the group but I don't want to have to go, I don't want to have to split and stuff. I don't want to have to split. Is there a way I can just I have to give all of them? I can convert to the date and times to a date time object, right? And just do math, do subtraction. Ah, that's right. You have to use the strip time. Ah. Okay, so yeah, exactly. Okay, I forgot about the strip time. My fault. So what we'll do is we'll put datetime dot strip time. Datetime. We'll call strip time on found index 0, and we have to give the this thing. How am I going to remember that? Oh, come on. %m, %d, %hour, %month, per millisecond, %second, close. So maybe we don't even need this. We'll get the open. We'll override it. We'll get the close. We'll override it. Then we'll calculate it. Okay. Okay, so now we're getting this. Experiment A failed after. Oh, it's doing this. If found equals n, print this, else print this. Okay, so then what we'll do is we'll get rid of this. We'll keep this. And I'll say else we're going to get a time. If found is equal to n, we're going to print this. Else print this. Why is that printing? Okay, so now if I want to so how do I convert? This is a time diff. We'll call dot total seconds, and then we'll floor this by 60 to get the amount of minutes. All right, solved it. Oh, that sucked. That one was really long. Holy cow, dude. Dang, man. That was pretty cool, though. We used regular expression, which is nice. Don't need that. How about remove the first and last line if start? Oh, here. And make it a function. Sanitize it. Okay, so then let's say, so this is just going to return back. Oh, okay, let's call a function here called, I get what you're saying. So we'll say def clean experiment given a string, right? This is going to be given an experiment, which is going to be of type, we're finding it all, of tuple. And then we're returning a string, right? So let's just take this out of here, and we'll say if not is instance experiment of tuple, we're going to raise a value error saying experiment or custom error experiment in non-tuple. Okay. So then we'll say if experiment, or if not experiment, we're going to raise another value error for a custom error, indicating that experiment tuple empty, no data. Okay, so then we'll say if found 1 equals to start, then we're going to get the start time else, and then what we'll do is we'll print this. So now what we can call here is clean experiment on the found, and then that'll do that for us. So now let's write a quick doc string here and say given an experiment tuple of parsed regex data from parse lines, clean the experiment tuple and return a string indicating the experiment label and time in minutes, right? So now if we run, shoot. There we go. Oh. Okay, so we don't even have to do, so this calls clean experiment with a optional start time. No, we call clean experiment. We We call clean experiment. If it's start, we get a start time. So we have to also pass in the start time. So maybe instead of looping, go on to it. We could use a two-pointer approach, right? So we need to figure out, we moved this out of its scope here. So the start time flag is not being picked up here and carried over. So then let's just go like this and return start time. Let's provide an optional start time equals to none, no, of type date time. Which will be default to none. So start time equals to none. I'll say here, return start time. No, because then I have to pass start time back into here. Right? Okay, so let's do it. The function get start time given right, and then also def get end time. Well, we already have the end time. Let's get start time. If we say if it's start, calculate out the start time. Clean it. Say get start time. We want to clean the start time, right? So let's go ahead and, or get the start time, which will go in place of here. But at least for like in the examples they gave me, yeah, right? Start, end, start, end. You don't have like a A that starts and ends down here with stuff in between. So yeah, I could take like a two-pointer and just calculate it out in one single loop, right? As I loop through here, I call find all on line and on line +1, and then calculate out the difference, and then clean it from there, basically, right? Let's try that. So let's say this. N is equal to the length. Do we already have an N? No. N is equal to the length of file lines, right? Let's do this. For I in range of file lines, or sorry, of N, right? We're going to call file lines index of I, R strip, right? File lines index of I is what we're going to parse over. This is going to be n minus 1, and we're going to set j equal to I plus 1, right? We're going to do the found start, and then the found stop equals to this for j, or I plus 1, really. We don't even need j. Right? Found start, found stop. We call it clean experiment. Let's go clean it, and then we'll call clean experiment on found start and the found stop. Index of 0, because it's a grouping, which is a list of matches. We only have one match, right? So we'll call clean experiment. So then our clean experiment, given an experiment, which is a tuple, a start experiment, and an end experiment, right? And an end experiment tuple. Yeah, that'd be good too. We could just do a dictionary, right? I mean, we don't have to really create the data structure because we're just gonna just clean it right here, right now. But yes, that would be a good idea if we wanted to like save it, right, into memory or something. Okay, so let's call a clean experiment. If start experiment and, oh my gosh, not is instance end experiment tuple, right? We're gonna write custom experiment if not start experiment and end experiment. Experiment tuple is empty, no data. Also go into the start experiment, right? We don't need this. We just need this to go here, delete that. Get an end time, which is just end experiment. We calculate a time diff. We convert it to minutes. And then we print if end experiment, right, index of 1 is equal to end, then we're going to print this. Okay, so print if experiment 1 equals to end. And then I guess we just turn here. Else, if you don't hit this with a fail, you print that. Now I'm getting fails for both B and C, which is interesting. If end experiment index of 1, right, equals to, quote, end, we're going to print this. Else we'll print this. Why and return? How do I get out of this? I'm gonna have to CD into all this crap. And put not of type list. Okay, customer input not of type list, customer input not of type list. Here, file lines. What? Why? What? I didn't change anything from before. Why is it throwing me an error up here now? The file is empty. No, we get it. Your oh. Return. Right, if we print return. So it's not reading my file. Experiment.log. Interview prep. Experiment log here. And here. What's going on? if the end experiment index of 3 on the tuple, which is here, that's that. Okay, good. We strip the time. To given an experiment tuple of partial expressions from first lines, clean. Okay, so we are getting some sort of bug here where we're printing things twice for some reason. Oh. We need to have a skip here. A stop. So we're going to start on 0, have a stop of n-1, and have a skip of 2. We're going to skip every other. There we go. Boom. Done. Clean. Cleaner this time around, right? So then this returns just right after that. Returns. So this also returns none. The lines of the and clean the groups into a string. Okay, let's quickly set this up. Let's go if underscore name is equal to dunder main. We're going to call main. We're going to copy this out around here. Main. Paste that here. And then just return. Parse line doesn't return anything. Okay, so then let's do a little one here. Let's say open the experiment log file and read lines text. Read and return lines. Lines per string. Okay, what do you guys think about this one? All right, let's go here. Okay, I solved it. This one was a lot harder than the last. It was not difficult. No, so I'll say it was a lot more time consuming than the last. I did enjoy the process though, and I used regex to parse, which is a huge bonus for knowledge. I was able to do this without help. I did have to look up the strip time method to know the formatting for the string conditional, though. That's a fantastic solution. Your ability to power through it with minimal help shows you're building exactly what kind of self-sufficient real-world coding muscle these startups look for. This is the kind of take-home or live coding solution that gives interviewers confidence. Let's go through and break down from both a technical interview and behavioral lens. Well, you absolutely nailed. You didn't overcomplicate it. This shows you're thinking flexibly and applying tools beyond the basics. Regular expression is not required, but it's impressive, especially in science-y data pipelines. Modern design, read, log, personalize, and clean experiment, perfect separation of concerns. Any of these could be unit tested, which shows good engineering habits. Date time subtraction, you correctly used total seconds divided by 60 and wrapped it in an int, clean. This shows comfort with one of the most error-prone standard library features. Error handling, type validation. If not is instance, strong habit protects edge cases. Return message are user-friendly and structured. Your code would fail gracefully, which is rare in timed interviews. Suggestions for tightening polish level. Minor logic cleanup. You're not reassigning this. It doesn't need to change the string in place. Oh, I'm not reassigning it, so it doesn't change the string in place. Okay, so our strip returns a new string back to us. It doesn't just do it. Or just completely ignore the entirety if your regular expression can handle a new line, which it does. Yeah, so we don't even need this because our regular expression is going to parse that out anyways. Print message, experiment name. You're grabbing the experiment name like this. If later experiments are named compound XYZ, this will break. Fix to use W plus $sign to capture the whole experiment name, not just a single word. Okay, so then let's call in our regular expression, let's fix our regular expression to include not a group here, but let's say a singular group where we have the word experiment, and then we do any character a number of times. Any number of times. Oh, it's plus? Let me look up regex key. Plus is match preceding character one or more times. Match any single character. So I'd have to match any character one or more times. Oh, 0 or more. So this is 0 or more times. So this, oh, okay. So it has to be there. It has to be there. It has to be there. So the difference between the star and the plus in regex is the star is 0 or more. The plus is 1 or more, meaning it has to be there. Okay, so now we just need to change. So this is group 0, 1, 2. So this is going to be experiment. We'll just say group 2 here, and then just delete this experiment out front. Perfect. Like so. And then go 2 here. And now if we run this, boom, even better. Nice. Oh, I can unpack them, right? Oh, with match.groups. This one's Meteor, 20 to 30 minutes, perfectly respectable time. You understood the domain. 9 out of 10. Let's go. 9 out of 10. Woo. Okay. We can move to a small data transform like pH classifier, smiles parsing, image simulation, or build toward a short script test file output. Are you winning, son? Hey, Dandy, how's it going, dude? Thanks for being here. We're doing some interview prep right now. We have a live coding interview for a startup, um, a chemistry software kind of startup on Thursday. So we're getting some practice here. It's already 9:20. We've already been going for 2 hours and 45 minutes. Oh my goodness. This one took us a longer because of the regular expression and the date time. Oh, wow. Jeez. Sheesh. Sheesh. Oh, okay. Should we try one more or do we call it here? I think I should do one more. Because we need. Let's go to 10 o'clock. Okay. Let's do one more here. Awesome, you're on a roll. Let's cap day one with one more real world style problem. This one will combine light parsing with basic domain logic and still stay grounded with vanilla Python. pH classification summary. You're given a file called phreadings.csv with a list of pH files recorded during a chemical titration experiment. Each line looks like this. Write a script that reads the CSV file, classifies each reading into one of the three categories. Prints out the summary like this. Oh, this is easy. Let's go. Okay, here we go. Let's do, this is going to be pH class, if pH classify. pH classification. Let's can I open a terminal at this file? Oh, I have to do it. Okay, so let's go new file. pH class .py. Let's do pH readings dot. Copy these. Oh, my title on Twitch has the wrong date. Oh, my bad. Shoot. I didn't know my Twitch title had the date in there the whole time. Oh, shoot. Let me go fix that real quick. Thanks for letting me know. Stream manager. How do I edit the stream? Record rates. Auto mod edit. Okay. Okay. There we go. All right, thank you for letting me know. I fixed that. Let's check to see where the stocks are now that the war is over, apparently. Oh gosh. All right. Looks good so far. Not bad. Not bad. Okay. All right, let's do this one. All right, it is 9:23. So let's see how fast we can do this one. Okay. So we just basically need to categorize these into, this is pretty simple, into lists then. and then take the length. Okay, let's go. Let's write a function. Let's do def main, right? And then we'll just say pass here for now. Let's call def. We'll say read ph CSV. We'll take in a path, which of type str, right? And this is going to return to us a, what are we going to return? We're going to return, let's use the dict reader. We'll figure this out in a second. So let's do with, so let's create a docstring, open the path open the phcsv path and read the data. Read the data into a dict reader. So let's import CSV here. Let's go with open. Let's open the path in read mode, right, with new lines equal to a blank string as file. We're going to say reader is equal to csv dot dict reader. We're going to iterate over the file here. So this is going to give us a dictionary, a list of so then let's call return a list of reader. If reader, else raise, I can't raise, do this, I have to say, okay. If not reader, raise value error, saying file or custom error. PH CSV empty. Okay. Else, what we're going to do is return list reader. Actually, let's call list on this. If not reader, we'll return just a reader. But we also need to have a try here. Except for a file not found error, we're going to raise about custom error. PH file not found. Okay. So nice. Now we got the read CSV, read PH. So let's call path is equal to PH readings dot CSV. We need to convert this into a string. Let's go ahead and call the read PH CSV on the given path. This is going to return a value of a list. So let's go ahead and do that. Woo! Thank you for the follow. Fontron. Appreciate you guys. Follower goal met. 150. Hey, 150. Let's go. Follower goal met. Thank you so much. Woo! All right. New line. So we call ph path, read path, which returns a data to us. Ph data. A list of dictionaries, right? So now let's go like this. We're going to format. So we'll call def sort pHs. For pH readings given a pH readings form of a list of dicts. Okay, we're going to return back a list of dicts. Okay, we're going to say sort the pH readings list based on pH value where less than 7 is acidic, equal to 7 is the neutral, and then greater than 7 is basic. Okay, so sort the pH readings based on pH value. So let's go ahead and write a function here to basically parse through for dict or for reading in pH readings. We're going to, first we need to say if not pH readings okay, then we'll also say if not pH readings. We'll also raise a value error of similar type. Say custom error pH readings empty. Okay, so for reading in pH readings, we're going to say if, we're going to say reading dict.get. We're going to get the value of pH, else none. So if categorize pH readings, so we'll say, we'll do this. Acid equals 0, neutral equals 0, basic also equals to 0. Okay, for reading dict in pH readings, if reading dict.get pH, so we're going to do this. This is going to be pH value is equal to this. If not pH value, we're going to pass. We're going to continue. Else, what we're going to do is take if pH value less than 7, less than 7, we're going to increase acid plus equal 1. If pH value equal to 7, we're going to increase neutral by 1, and else, no, we don't want to have if, elif, we can just do this, and then we're going to continue. So we're going to return basic in a tuple like this. So let me call actually I'm going to return a dict. We'll do this. And we'll do this basic. Right? And then we'll call categorize pH readings given pH data. And then we're going to call a function called neutral basic. Okay, so then we'll say this. We'll call display or print pH reading, pH counts. Right? Given pH counts. So now let's write a function called def pH counts, or print pH count, sorry. Given pH counts, which is a dict, we're going to return none here. So for, so we're going to say for key value in pH counts dot items, we're going to print the key dot title, and then we're going to print this. We're going to do the length. We're going to print out the length of the value. Or no, we just print out, sorry, the value. It's a count already. Those are readings. Okay, so let's just do some quick things. So print a formatted count of acidic, neutral, and basic. Okay, and so what we're going to do is say if pH counts, no, if is instance pH counts, if not dict, right, we're going to raise a value error with as a custom error where we will say pH counts input not of type dict if not Okay, that's fine. So we could add another check here, basically say like if pH counts dot keys equals to right, a set of acidic neutral and basic, if pH keys equals to this set, if it's not equal to it, then we'll raise a value error saying invalid dict input. Missing or invalid keys. So now if I call if experiment log cd pH now if we run, oh, oops, sorry. It's a float. Okay, so okay, so we'll just get rid of this. There we go. All right, this one's solved. Boom. Okay, let's take this one. This one was took a This was clean, fast, and professional, and exactly how you wanted to end day one. Here's a breakdown, interview or take. You're moving fast, writing clean, and modern modular code, and solving the problem without over-engineering. This is exactly what we want in a coding review, especially when focused on real-world tasks. Use handled less than is equal to and greater than properly. Use continue thoughtfully. You could drop it, but it's fine here. Elegant use of a dictionary return. The kind of structured return is super readable. Interviewers like it when data flows cleanly. Readable output format. Looks great and makes your output user-friendly. Consistent error handling. Float conversion edge case. Right now I'm doing this, but you check for none. Okay, so if not pH, I continue. Else I call the float. Okay, so if pH, if not is instance pH value of type okay, so you would just try and accept. So try, right? You try to cast the float, except if you get a value error, or type error, we're going to continue. So elif, if this isn't true, this will be tested. Else, then we can remove the continues there. Ooh. There we go. Perfect pass, polished pass. You're now rock solid, robust, and interview ready. Let's give a quick final evaluation of this version so you exactly know what to read in an interviewer. Exceptions say float parsing, clear and complete final output. This is tidy, human readable, and interviewers love it. 10 out of 10. Let's go. Hey, Fernando. Thanks for coming in, dude. Greetings from Peru. I study every day around 7 p.m. PST. So thanks so much for coming in tonight. We studied for 3 hours and 10 minutes tonight, solving 3 separate practice problems, going over, loading data from a file, using both just text with read lines and using DictReader with CSV. Right? So we solved 3 problems here. If you guys would like access to the code, let me know and I will go ahead and I'll make a repo and give it to you guys if you guys want access to these practice problems. I kind of want to grab the prompt. So let me grab the prompt here from each of these. I'm going to take the prompt and I'm going to put them within here. Okay. So I'll rename this as mass. And now this is prompt. Okay, let's go find the other prompt. Okay, practice prompt number 2. Copy image. Let's go to experiment log. Paste. Rename. Okay, and then let's do the last one. Practice problem number 3. Copy image. Paste. All right, cool. I'm going to rename this to day 1. All right, cool, you guys. So I'll keep a log of these problems as I go here of these course these next 3 days, and I will go ahead and share this with you guys at the end of my 3-day session here, for you guys to also practice some interview type problems, some like real world Python scripting problems that potentially we might be asked in an interview. I'm doing this style because in the interview notes it said that data structures and algorithms memorization was not required. So I don't think that they're going to ask me a leak code problem. They're probably going to ask me a problem like this, where they're going to have some sort of data, extract out the data, do something with it, and report back some sort of yada yada yada. So that's why we're doing this kind of style rather than the leak code, because we're just getting some practice with some more real world stuff. Now I will say that um, if companies are going towards this type of format away from leak code and more towards real world type of problem solving and scripting, that's really really cool, because a lot of my practice within my projects actually is applying like my regular expression, like we wrote that within my spectrosim that directly applied, and like I remembered all of that stuff from that project that we wrote, my file parsing from my other projects, from my um, like my small business manager, like all of these actual projects are really starting to actually, you know, the things I learned in those projects are starting to really, take place and come up here in these types of real world problems. So it's kind of interesting that I think maybe companies are shifting away from leak code and starting to do these kind of styles, which is really kind of cool. So thank you guys so much for being here and joining me. I appreciate you guys hanging out with me tonight. We have a interview for a software engineer chemistry position on Thursday at around lunchtime. So, wow, what time do you wake up? I'm trying to study in the afternoon, but I can't focus. Yeah, dude. So for those that are new here, I'm 26. I have a degree in human biology and a minor in chemistry, and I work as a professional formulation chemist for a biotech company right now, a full-time job. And then I code and stream every single day afterwards. So I do put in 12 11-hour days every single day for the past like year, teaching myself how to code after my 9 to 5 job. So the grind is real. Um, and so, anyways, we did 3 practice problems today: a mass analysis, a pH classification, and an experiment log kind of parsing. And we were able to complete these problems in about 3 hours, completing all 3 there, so about an hour each. So not the best. We do need to speed up and be faster. So maybe they won't ask us as like long of problems. They might ask us more, maybe like 1 function problems rather than like 5 function problems. I'm not sure. I really am quite curious to what they're going to ask me. So I'll report back. Hey, Death Steel. Yeah, so I have an interview for a software engineer chemistry position, a live coding interview on Thursday. So I have to practice here. I'm practicing up my file I/O extraction, data parsing. I'm practicing, conditionals over data, using 2 pointers to parse data rather than, O of n solutions, keeping it O of n, I mean O of n squared, keeping it O of n, all that jazz. So I'm really excited, but I'm also really, really nervous. I'm gonna be honest with you guys. I, but at the end of the day, we've put in a lot of practice. So I'm just gonna go and do my best and learn from this experience. It's my first time ever interviewing for a software engineer position. I'm pretty lucky to be in this situation. So um, yeah, it's gonna be good experience. Like that's what I said. Exactly. It's my first time ever interviewing for a software engineer position. I don't have a degree in CS, so Like it's really going to be kind of interesting to, feel out and see how what they're looking for. I do believe they are looking for someone more like science oriented in like chemistry though, that can do things in Python. So I do think that the fit is very, very nice with the company. I do think I could be a very, very good fit and provide what they're looking for, especially with my current projects like the SpectroSim, the the chromaplot.com, like all those kind of chemistry projects that I made really, really is going to hopefully show our skills. So we'll be back tomorrow to continue on with some more practice problems. What is the plan for tomorrow? Let's look. What is the study plan for tomorrow? Day two, intermediate system design plus domain-specific tools. You'll write slightly larger, more interactive scripts that simulate actual problems you might encounter on the job, especially at a biotech or data-focused startup. Work in structured mini sessions where you'll get a short prompt, ask clarifying questions, code with minimal help, and reflect on your approach and polish. Yeah, it's a really nice fit. They're a software, LIMS, like inventory management system company, and like software automation company for lab techniques and things. So I could provide a really, really nice perspective from a wet lab experience as a chemist, coming from having 3 years of actual formulation wet lab experience, as well as, you know, all of my undergrad actually being in the lab doing experience. Also in my undergrad, I was the undergraduate teaching fellow for the chemistry department, so I ran and administered all of the final, the testing and the finals study sessions and everything for all the students in the department. I had like hundreds of people show up at once that I was teaching like a giant lecture hall to in like a room or on Zoom sometimes. And then I was also as an undergraduate, I was the only undergraduate with the grad students as a laboratory instructor for the general chemistry course. So I I went to the lab instructor, the professor, and I was like, hey, I know I'm an undergraduate. I really would like a job, running these labs. I want to gain experience, administering labs and whatnot. And so he said it's not only for grad students, but he'll make an exception. And so I was able to get a job my senior year of college as a lab instructor. And so I had to grade the general chemistry, like all the lab reports. I gave people grades. Like I literally gave them their college grades. I was a pretty easy grader. I'm a chill guy. But yeah, we had a chill lab. We had music going, and it was fun. Anyways, you guys, thanks so much for hanging out with me tonight. I appreciate you guys being here and hanging out with me. We streamed for 3 hours and 20 minutes solving three kind of Python scripting problems where we had to access data within a file, be it a text or a CSV. We had to parse the data with either a regular expression or with reading lines or with dictionaries and dict reading. And then we had to extract out various informations and reformat it into a specific organization category thing. So thank you guys so much for being here for today's study session. I'll be back tomorrow to continue on. My interview's on Tuesday, so 1 day down, 3 days to go, or 2 days to go, really. So really nervous, honestly. If you guys have any tips, regarding what you saw today, me coding live, let me know if you guys have any tips for me. And things I should improve on or focus on. I didn't like make any comments. I did have my type hints and my doc strings and whatnot, but I didn't make any comments anywhere, which is kind of a blunder. But the code wasn't really so advanced that I needed like comments, but I'm sure they would like to see comments. But anyways, sorry, I'm rambling on. I'll see you guys tomorrow. Thanks so much for being here, and I'll have a good day. Message me on Discord, also link down below. Join my Discord completely for free if you want a roadmap of my entire learning journey, every book, website, course I've taken so far. I haven't spent a single dollar on programming and teaching myself. I've used all free resources, and I provided those guys to you as well. So thank you guys so much for being here. Have a good one.